Hello friends, through this video we will learn the cement as basic construction material, ingredients of cements, tests procedure on cement. If you like the video, please do share it and subscribe the channel. Cement is a binding material. It is made by grinding calcined limestone and clay to a fine powder. Cement can be described as a material with adhesive and cohesive properties which make it capable of bonding materials into a compact whole. For construction purposes, cement is restricted to bonding with materials like stones, bricks, building blocks, aggregate, etc. Natural cement is obtained by burning and crushing the stones containing clay, carbonate of lime and some amount of carbonate of magnesia. Natural cement is brown in color. It sets very quickly after addition of water. It is not as strong as artificial cement. Artificial cement is obtained by burning at a very high temperature, a mixture of calcareous and argillaceous materials. Common variety of artificial cement is ordinary Portland cement. This cement was invented by a mason, Joseph Aspden of Leeds in England. After setting, this cement resembles a type of sandstone in Portland in England. It is therefore popular as Portland cement. Ingredients of concrete. Functions of cement ingredients. The functions of various ingredients of cement are as follows. Lime, CaO. This is the important ingredient of cement. Its proportion is to be carefully maintained. Lime in excess causes the cement to expand and disintegrate. If the proportion of lime is less, the strength of cement decreases, and cement sets quickly. Silica, SiO2. Silica gives strength to the cement. This is an important ingredient of cement. Alumina, Al2O3. Alumina imparts quick setting property of cement. Alumina in excess weakens the cement. Calcium sulfate, CaSO4. This ingredient is in the form of gypsum. Its function is to increase the initial setting time of cement. Iron oxide, Fe2O3. Iron oxide imparts color, hardness, and strength to cement. Magnesia, Mg. If magnesia is present in small amount, it imparts hardness and color to cement. Sulfur, S. A very small amount of sulfur is useful in making sound cement. If it is in excess, it causes the cement to become unsound. Alkalis, as most of the alkalis present in raw materials are carried away by the flue gases during heating. Cement contains only a small amount of alkalis. If they are in excess in cement, efflorescence is caused. Manufacture of ordinary Portland cement. The process of manufacture of cement consists essentially of grinding the raw materials, mixing them intimately in certain proportions, burning in a large rotator kiln at a temperature of about 1450 C. Due to this temperature, the material melts and partially fuses into balls known as clinkers. The clinker is cooled and ground to a fine powder, and a small percentage of gypsum is added. The product formed is commercial Portland cement. Cement is manufactured in either A. Dry process or B. Wet process. Dry process. In this process, the raw materials are first reduced in size of about 25 mm in crushers. A current of dry air is then passed over these dried materials. These dried materials are pulverized into fine powder in ball mills and tube mills. All these operations are done separately for each raw material, and they are stored in containers called hoppers. They are then mixed in correct proportions and made ready for the feed of rotary kiln. Dry process is adopted when the raw materials are hard. Advantages of dry process. It increases the productivity of labor. The capital required for manufacture of ton of cement is less. The fuel consumption is reduced. Disadvantages of dry process. The process is slow. Cement produced is of inferior quality. Wet process. 1. Mixing. In this process, Calcareous materials such as limestone are crushed and stored in storage tanks. Argillaceous materials such as clay are thoroughly mixed with water in a container known as wash mill. The washed clay is stored in basins. Now, crushed limestone from silos and wet clay from wash mill are allowed to fall in a channel in correct proportions. This channel leads the materials to grinding mills where they are brought into intimate contact to form slurry. Grinding is carried out in ball mills or tube mills or both. The slurry is led to correcting basin where it is constantly stirred. At this stage, the chemical composition is adjusted as necessary. The corrected slurry is stored in storage tanks and kept ready for burning in a rotator kiln. 2. Burning. A rotator kiln is formed of steel tubes. Its diameter varies from 250 cm to 300 cm. Its length varies from 90 m to 120 m. It is laid at a gradient of about 1 in 25 to 1 in 30. The kiln rotates once in every minute about its longitudinal axis. The corrected slurry or raw mix is injected at the upper end of the kiln. Hot gases or flames are forced through the lower end of the kiln. Portion of the kiln near the upper zone is known as dry zone. Here water of slurry is evaporated. As the slurry gradually descends, there is rise in temperature, and in the next section of kiln, carbon dioxide from the slurry is evaporated. Small lumps known as nodules are formed at this stage. These nodules then reach the burning zone where the temperature is about 15000 C to 17000 C. In burning zone, calcined product is formed. Nodules are converted into small hard stones known as clinkers. The size of the clinkers varies from 5 mm to 10 mm, and they are very hot when they come out of the burning zone. A smaller size rotary kiln is provided for cooling the clinkers. Grinding. Clinkers as obtained from the rotary kiln are finely ground in ball mills and tube mills. During grinding 3 to 4% of gypsum is added. Gypsum controls the initial setting time of cement. If gypsum is not added, cement would set as soon as water is added. Field tests for cement. Following field tests are carried out to ascertain roughly the quality of cement. Color. The color of cement should be uniform. It should be typical cement color, gray color with greenish shade. Physical properties. If cement is touched or rubbed in between fingers, we should feel smooth. If it is felt rough, it indicates adulteration with sand. If hand is inserted in a bag of cement, it should feel cool. If small quantity of cement is thrown in a bucket of water, it should sink and should not float on the surface. Presence of lumps. Cement should be free from any hard lumps. Such lumps are formed by the absorption of moisture from the atmosphere. Any bag of cement containing such lumps should be rejected. Strength. Cement briquettes of size 75 mm x 25 mm x 12 mm are prepared with a proportion of cement to sand as 1:6. The briquettes are immersed in water for 3 days. If the briquettes are not easily broken and it is difficult to convert them into powder, it indicates cement of sound quality. Tests on cement as per I.S.I. The following tests are conducted on cement as per I.S.I. 1. Fineness test of cement. This test is carried out to check proper grinding of cement. Fineness of cement particles may be determined by sieve test or by permeability apparatus test. In sieve test, cement weighing 100 gm is taken. It is continuously passed for 15 minutes through IS sieve number 9. The residue is then weighed, and this weight should not be more than 10% of original weight. Weight of cement sample taken equals W1. Weight of sample passing through IS sieve number 9 equals W2. Weight of cement sample retained equals W1 W2. Fineness equals 100x, W1 W2, /W1. In permeability apparatus test, the specific area of cement particles is calculated. Specific surface of the cement should not be less than 2,250 square centimeter per gram. 2. Consistency test. The performance of this test is to determine the percentage of water required for preparing cement paste of required workability. 4. Consistency test plunger is attached to the movable rod of the VCAT apparatus. The following procedure is adopted. Take 300 gm of cement and add certain percentage of water to it. Mix water and cement on a non-porous surface. Mixing should be done thoroughly. Fill the mold of VCAT apparatus and keep the mold on a non-porous plate. Plunger is attached to the movable rod of the VCAT apparatus and it is gently lowered on the plate in the mold. The settlement of the plunger is noted. A penetration of 5 mm to 7 mm indicates consistency. 3. Initial and final setting times of cement. Initial setting times and final setting times are determined by fixing square needle and annular needles to the moving arm of the VCAT apparatus. For good OPC, the initial setting time should be around 30 minutes and final setting time about 10 hours. Procedure for initial setting time. Cement weighing 300 gm is taken and it is mixed with percentage of water as per consistency. Cement paste is placed in VCAT mold, placed over a non-porous plate. Square needle of cross-section 1 mm x 1 mm is attached to the moving rod of VCAT apparatus. The needle is allowed to penetrate cement the paste. Initially it penetrates completely. It is then taken out and dropped at a fresh place. This process is repeated at regular intervals till the needle does not penetrate completely. Initial setting time is the time interval between the addition of water to cement and the stage when the needle does not penetrate completely. This should be about 30 minutes for ordinary cement. Procedure for final setting time test. Cement weighing 300 gm is taken and water as per consistency is added to the cement. This cement paste is placed on the VCAT mold. Needle with annular collar is attached to the moving rod of the VCAT apparatus. This needle makes an impression on the cement paste. The time at which the needle and collar fails to make impression on test block is noted. This time corresponds to the final setting time. This time should be around 10 hours for ordinary cement. 4. Compressive strength. To determine the compressive strength of cement, the following procedure is adopted. A cement mortar of proportion 1:3 is prepared. Water is added to the mortar. Water-cement ratio of 0.4 is taken and mixed thoroughly. The mortar is placed in the molds. Molds are test specimen in the form of cubes of size 70.6 mm or 76 mm. Cement required is 185 gm and 235 gm respectively for 70.6 mm and 76 mm size. The mortar in the mold is compacted in vibrating machine for 2 minutes. The molds are placed in damp cabin for 24 hours. The specimen is then removed from the molds and they are submerged in clean water for curing. The cubes are then tested in compressive testing machine at the end of 3 days and 7 days. During testing, load is applied uniformly at the rate of 350 kg/cm2. Compressive strength at the end of 3 days should not be less than 115 kg/cm2 and at the end of 7 days it should not be less than 175 kg/cm2. Ordinary Portland cement, OPC. It is obtained by burning calcareous and argillaceous materials at high temperatures. The color of the cement is gray with greenish shade. Its initial setting time is 30 minutes and final setting time is 10 hours. The expansion in soundness test is less than 10 mm. The cement contains not less than 2/3 of its mass made up of C3S and C2S taken together. A small quantity of gypsum is added. Most of the cement used for construction is ordinary Portland cement. Quicksetting cement. This cement is produced by adding a small percentage of aluminum sulfate and by finely grinding the cement. The percentage of gypsum is reduced considerably to reduce the setting time. The setting action of cement starts within 5 minutes of adding water to cement and it becomes hard like a stone in 30 minutes. Thus the initial setting time of the cement is 5 minutes and the final setting time is 30 minutes. Sufficient care should be taken to complete mixing and placing of concrete in a short time. Rapid hardening cement. Initial and final setting times are same as that of ordinary cement, but it attains high strength in early days. This cement is burnt at high temperatures, its lime content is increased and it is subjected to very fine grinding. This cement is costlier than ordinary cement but it has the following advantages. Advantages. As it sets rapidly, construction may be carried out fast. Formwork of concrete can be removed quickly. It obtains strength in a short period. It is light in weight. It is not damaged easily. Structural members constructed with this cement may be loaded earlier. This cement requires short period of curing. This cement allows higher permissible stresses in the design. White cement. This cement is prepared from raw materials which are practically free from coloring oxides of iron, manganese, or chromium. It is white in color. It is used for floor finish, plaster work, ornamental work etc. It should not set earlier than 30 minutes. It is more costlier than ordinary cement. It is specially used for preparing different colors with oxides for flooring with tiles. Portland Pozzolana Cement, PPC. In preparing this cement a volcanic powder pozzolana is added to the Portland cement. It is specially used to resist the action of sulfates. The percentage of this pozzolana is 10 to 30%. Following are the advantages of this cement. It attains compressive strength with age. It can resist action of sulfates. It evolves less heat during setting. It imparts higher degree of water tightness. It imparts plasticity and workability to mortar and concrete prepared from it. It is cheap. It offers great resistance to expansion. It possesses higher tensile strength. The following are the disadvantages of this cement. Its compressive strength in early days is less. It possesses less resistance to erosion and weathering action. This cement is used to prepare mass concrete of lean mix and for marine structures. It is also used in sewerage works and for laying concrete in water. Thank you for watching the video. If you like it, please do share it and subscribe the channel.